Some hybrid vehicles like this Chevy Volt behind me have an auxiliary electric coolant pump that circulates the coolant throughout both the engine and the battery packs in order to keep them cool. Now, when you refill that coolant system, a lot of times you have to do a bleed procedure in order to get all the air out of the system. So let's walk through it. Okay, so this test is under the hybrid powertrain control module number 2. And if we go in there, it's under functional tests and is a special function. And we see we have the hybrid EV battery pack coolant pump bleed procedure. Go in there. And it says refer to service information when using this test. Connect the required equipment. Connect the battery charger to the 12-volt battery. Vehicle must remain in service mode during this procedure. Now, the required equipment that it says, if you look inside the service information, these need to be vacuum filled. So you need to use a special vacuum fill coolant filler. So really just walking you through the procedure here so we don't have any of that hooked up, but just make sure you check your service information for that. So I'll just hit continue to trigger the test. It says make sure the proper coolant level is in there, and then the procedure will run for about 30 minutes, and you can exit the procedure at any time if you wish to do so. So I'll hit continue. It's going to go in, it's going to start the tests, and you can see the numbers are starting to change there. If I open a couple graphs, you can see there it's the percent that it's commanding it on. So it started at 6%, it's all the way up to 50%. And it's cycling through on the pump. So you can see what's going on there. So once the procedure is complete, a final screen is going to come up to tell you that the process is complete. And once all that's done, you've bled all the air out of the system and the job is done. Hello everyone, welcome. Thanks for joining our diagnostic training session today. Now, if you have any questions throughout the session, if you're joining us on Zoom, just look at the top of the bottom of your screen, wherever your Zoom controls are. You should see a little button that says Q&A. Click on that, type in your question, and I'll get to those at the end. If you're watching on YouTube, just feel free to use the live chat function if you're watching it live. Otherwise, you can leave a comment, and I will get to those at the end. So my name is Jason Gabrinas. I'm one of Snap-on's national diagnostic technical trainers. Been in the training department the last 12 years or so, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep with Snap-on, so I had about 30 different franchisees I worked with, as well as the shops that they serviced in order to help everyone get the most out of their diagnostic needs. And before I did that, it was 8 years at Subaru, so worked as a tech under the hood, and over that time just became that default diag guy in the shop. So I always ended up with the drivability problems, the intermittent problems, the weird wiring problems on those cars. And that's really where my interest in diagnostics started, because I always liked working on those. Before that, a bunch of other miscellaneous wrenching jobs. We're looking at about 30 years under hood experience for me. Our topic tonight is hybrid and EV diagnosis and repair. So we haven't talked about hybrids or EVs in a little while. It's been a couple years. So we're just going to go through, talk about some of the similarities, the differences, kind of how, because there are a lot of similarities between them, because basically a hybrid's an EV with an engine and a smaller battery most of the time, right? So a lot of similarities, a lot of differences, and a lot of scan tool functions you might need to do that. So first off, we'll start with electric vehicles, just your base electric vehicle. And it is basically a battery on wheels. Most of these EVs nowadays, the battery packs fill up most of the vehicle. Some of them are even structural on some vehicles. So it's like part of the frame underneath, basically. So you just take the whole thing out. There's special lifts that are used to lift the batteries because they weigh a lot. And then they have an electric motor in there. Now, depending on what the manufacturer is, different manufacturers do it different ways. If it's a purpose-built EV from the ground up, never had an engine, the gasoline engine or diesel engine in it, then they're just going to put the electric motor in it and kind of build it around the motors. Could have front and rear motors, that sort of thing. On a hybrid vehicle, most of the time, it would have already had a gasoline engine in there, or if it's a vehicle that has a gasoline variant and an EV variant, the electric motor for the EV is going to look very much like an engine, gasoline or diesel engine in the front of the vehicle. That way, it just makes it easier in production. Oh, this one's going to be an EV. We're just going to slap a bigger battery and we'll throw a gasoline engine in it. Call it a day, basically. So depending on what the vehicle is, who the manufacturer is, whether it's purpose built from the ground up to be an EV or if it was originally a internal combustion engine, we'll say it that way. Depending on how it was built, it will depend on the size of the battery and how the electric motor is configured. So let's walk through the components. So as I said, battery, main component of an EV, battery cooling and heating system because we need to keep it cool and we need to keep it warm in the winter. So often, depending on how the manufacturer does it, some of them are electric heaters. Some of them just use the coolant that's circulated throughout the vehicle, just to heat it or cool it. They can do that way. Voltage converter in there because we've got to take the 300-400 volts that are coming out of the high voltage battery and convert it down to 12 volts sometimes or 48 volts depending on the vehicle. They'll have a regenerative braking system. So when you let off the accelerator, it'll use the mass and slowing of the vehicle, basically runs the generator or the motor pack in reverse. So it charges the battery that way. Of course, the electric motor, that's going to be the heart of the system. Well, I guess minus the battery. But that's really what makes it goes, connected to the wheels and a charger, of course. So you need a charger to actually plug it in to the wall or to the electric charger station. So yeah, those are your basic components. Now, of course, we want to say safety first. I would be remiss if I don't talk about this. So the battery is high voltage, and in this case, I believe this is from Toyota. High voltage system may remain powered up for up to 10 minutes after the vehicle is shut off or disabled. To prevent serious injury or death from severe burns or electric shock, avoid touching, cutting, or opening any orange high voltage power cable or high voltage component. Both positive and negative cables are insulated from the metal chassis, so there's no possibility of electric shock when touching the chassis, as long as you don't have a fault. Ground fault monitor continuously monitors for high voltage leakage of the metal chassis while the vehicle is running. If a malfunction is detected, the hybrid vehicle computer will illuminate with a master warning light and image cluster and say check hybrid system. And the relays will automatically open to stop electricity flow in a collision sufficient to activate the airbag. So this is off a hybrid vehicle, but it'd be the same for just a straight electric vehicle. The battery, it's going to be multiple small low voltage batteries linked in series. So they're usually around like 3-volt smaller batteries, and then they link them together to get, and usually it's in the 300 to 400 range. I put plus in there, but it's not that common to have more than 400 volts going through the system just because most manufacturers design them to be up to 400 volts. It's nickel metal hydride or, of course, lithium ion. We hear about that all the time too. EVs have large packs and they're quite heavy. Like I said, special lifting equipment needed to get them out of the vehicle. There are companies out there now, actually they've been out for a while, that what they do is they'll take, if we got a pack with bad cells or whatever, they'll just take it out of the vehicle, disassemble it safely because they know how to do it. And then they'll go in and rebuild whatever packs. Maybe there's some corrosion in there. They clean that up on the bus bars and maybe throw a couple new packs in there, and then you have just a refreshed battery. So there are businesses that do that. They've been doing it since back in the Prius days. So it can be done. You just got to be careful how you do it. By the way, in the United States, North America, I guess in general, I'm not sure about Canada, but in the United States, anyways, there are 0 certifications to work on EVs or hybrid vehicles. You don't need one. You can just say, hey, I want to start working on EV and hybrid vehicles and go to town. Now, it's probably not that best idea unless you get some more training than what I'm going to give you tonight. Put it that way. You want to be really careful, but this is by no means an in-depth EV class. This is kind of an overview of the state of where we're at, and how we can work on it with a scan tool. But when it gets to actually going into the high voltage system, you probably want to take a more substantial class. I know over in Europe, we offer an EV class. It's like a couple days, I believe, or it's at least a few hours. It's like half a day at least. I'm not sure. I haven't really studied into it because we don't need it over here. But anyways, you do want to go and get more training if you're going to work on EVs and hybrids. Of course, we talked about earlier battery heating and cooling. So batteries must be cooled to maximize performance in life. There's really a good sweet spot where they want to be as far as their temperature in order to take the most charge and to be the most effective. 3 methods are used: passive air cooling, which isn't that common. It's just using the air flowing as you're driving. Active air cooling, which would be fans, cooling fans, that's more common. And then liquid cooling as well. So in this case, we're showing a liquid cooling for the vehicle. This is on a Audi e-tron. So liquid cooling can also warm the battery if needed. So where I live, it gets pretty cold out there in the winter. So oftentimes you would want to have a system where you could warm the battery. The coolant flowing through it must contain deionized water, and coolant is either warmed or chilled depending on what's going on. So we have a heated battery module and a battery chiller right here in this example. So you got a heater and a chiller, and then you got a valve that'll bring the heated or the cooled coolant through depending on what it is. Electric water pump in there, of course, and it's going to have a radiator just like an internal combustion engine vehicle. Also, the converter inverters convert AC to DC, converts high voltage to 12 volts for the low voltage system, and also oftentimes will have a auxiliary battery. It reverses the step up to charge the battery while braking as well. So it's got a control unit, does DC low voltage, AC conversion, and DC high voltage. 12-volt battery is going to run things like your stereo and your sometimes your HVAC. All the doodads and stuff that normally run off 12 volts in your car, it's going to still run off 12 volts. So that stuff is easy enough to fix because it's the same procedure you'd use for a regular 12-volt vehicle. The high voltage battery assembly, in this case, you see 360 volts, got a joint box, and then it goes into the control unit, which splits it off to where it needs to be. Because the motor oftentimes is going to use AC to go to the motor, right? So there's a joint box again, battery management system, brake switch, shift lever, low voltage there, 360 goes in, 12 volts comes out, and so on and so forth. So that's a little bit more of a look into that system we were just looking at. The regenerative braking system transfers energy from braking to charge the battery and uses the electric motor as a brake. And in essence, the motor becomes a generator. It works in reverse. They also do have hydraulic brakes on the vehicle, but the first stop is going to be the motor, using a reduction gear through the motor, and then it's going to go through and charge the battery. Now, I will tell you, first time I drove a Tesla, I decided I would never buy a Tesla just because of this. I've driven other hybrid vehicles, and it's not that bad. I've never driven a full electric vehicle, so I'm not sure how the others are. But man, that Tesla I drove, as soon as you let off the accelerator, it's like because the motor generator is going, and it's using it as basically an engine brake. So every time you lift off the throttle, it would basically slow down ridiculously fast instead of just kind of coasting. And I did not like that, so I said I will. Driving that vehicle, that just made me not want to own one, just from that. And I'm sure some of you are the same way. Others of you probably have other opinions on why you wouldn't want an electric vehicle, but they're out there and they're not going anywhere, so we need to learn how to work on them, right? Electric motor is going to use high AC voltage, sometimes 500 volts or more, and it's usually a three-phase AC motor. Used to drive the wheels, of course, and then also used to charge the battery during that regenerative braking period. So just be aware it could be high voltage, and oftentimes it is AC three-phase. So it just kind of depends on what it is, but that's what you're going to get out of it. Also in there, it's going to have what they call a motor resolver. So it's basically using position data to know where this rotor is in space, so it knows how fast it's going and all that. And there are special functions and special tests that you may need to do to reinitialize the resolver if you do any work on that. So it's kind of like I guess you want to call it kind of like a crank sensor or a RPM speed, engine speed sensor, that sort of thing. So yeah, it's got a plug that goes in, and then of course it's going to have the resolver as part of it, and it's going to also have your three phases in there. So it's kind of like a brushless DC. It's kind of like a brushless motor. Actually, I think I did say it's a brushless AC. No, just three-phase AC. But it's going to work in the same way like a DC brushless motor would, with the three phases, the UV and the W. So we have three-phase electricity goes in there, and the motor control unit goes into the actual traction motor. So this is high voltage. There's your three-phase that goes in there. And then it also has the resolvers, and there's multiple other resolvers on there as well. So 1, 2, 3, 4 different resolvers that'll go into the motor control unit. And you would have to go in, and like I said, if you ever did any work on this, did something with the resolver, did something with how the engine was set up, you would have to go in and reset that, relearn it. And then in there, instead of a transmission, it's going to have a reduction gear inside, like a reduction gear assembly. So input goes in, and then it goes out to the wheels. in lieu of a transmission. So it reduces rotational speed and increases torque depending on how how it's set up and how they choose to use that reduction gear. So it's got a first and second reduction gear, parking gear as well in this case, differential gear down the bottom to go out to the two different wheels. So instead of using a transmission, you're not going to see that. You're going to see this reduction. Now, of course, the high voltage battery must be charged. There's an example of a charging plug. Home chargers and charging stations can be used depending on what it is. Regenerative braking also provides some charge, but it's not going to be a lot unless maybe I'm in the Rockies and I'm coasting down a mountain for a while. That might charge it up decent, but um, your mileage may vary and your charging speed may vary depending on how much is available. So in this case, this is a schematic. It's got normal charging. We'll go through the onboard charger and I'll charge the system thusly. Just kind of go through the system there and charge the high voltage battery. Quick charging goes in kind of double, so it's got two relays in there that'll switch over, and pretty much it just gives it straight to the high voltage battery right through. So it's two different ways to do it, two different charging schemes, two different charging systems, but both will work with the vehicle. And here's just another example of the couple relays in there. Quick charge relays will turn on when it recognizes that it's coming from a quick charger. From the charging connector, it's got an interlock there, and then it just takes and goes right through, and that'll give you a quick charge right there. As far as diagnosing, due to the complex electronics in there, diagnosis is usually just with a scanner. Usually they'll just say, hey, you need to hook it up with a scanner and look at these different PIDs or something like that. High voltages require caution working on many components, as we said. 12-volt systems can be diagnosed like any other vehicle. So if I have a radio or some of the HVAC controls, seats, wipers, any of the normal 12-volt systems is going to be just like any other 12-volt system that's out there. But like I said, most of them require, hey, you're going to look at these different PIDs, or you're going to look through this data, you're going to look through that functional test, that sort of thing. And same thing with component testing. Complex electronics, usually they're demanding a scanner, not a component testing. There are some component tests that we do have, and I'm going to show you some in a little bit. A lot of the articles in the component tests are also going to be just kind of talking about how it works. High voltages require caution. 12-volt systems can be diagnosed like any other vehicle. Most high voltage systems are not suitable to test with an automotive scope. All right, so we go up to 400 volts DC, we say. But that is, I believe, in transient. So you wouldn't want to hook up our scope to any of the orange wires unless you knew they were like 48-volt wires, and it'd be okay. But as far as the high voltage wires, no. So what is a hybrid vehicle? Hybrid vehicle is going to be a battery, but usually much smaller battery, and then an internal combustion engine paired up with the battery. So sometimes it runs on the engine, sometimes it runs on the electric, sometimes it kind of does both. We'll talk about power flow here in a little bit, but we'll see. It's got a gasoline engine in the front. This is most likely a Prius. I don't remember what I took it from, but it's going to have your motor in the front, and it's going to have a much smaller battery. You see, it doesn't take up the entire underbelly of the vehicle. It's going to have a smaller battery underneath the rear seat. And then in this case, looks like might have a rear motor in it as well for all-wheel drive. So there's a couple different powertrain types that we're going to be seeing in the hybrid world. So parallel is the most common design. So it's going to be gas and electric motors that are linked to a common transmission. So it's just kind of be this whole package together. As I said, this is usually going to show up on a vehicle where it also has a internal combustion engine option only, no hybrid option. So a lot of Toyotas are like that. You're going to get into like your Hyundais are going to have that too, where you're going to have your gas engine and you're going to have your hybrid engine available. Generator and motor are generally grouped in the transmission assembly, or where you'd see the transmission assembly. They don't have a traditional transmission as you would suspect. It's going to be that gear reduction again, right? So there's the electric motor gear reduction, and that's the motor generator right there. There is a series option as well. It's just a much less common design. It's only used on a few different vehicles. The BMW ID4, I think, with the long range option, whatever the extended range option is on that, it's going to use this. Electric motor is going to drive the vehicle, and the gasoline engine is only used to charge the high voltage battery. So that's the extended range thing. So the engine is not hooked up to the drivetrain at all. It's just there to charge charge the battery in the vehicle. And that's it. Doesn't actually provide any power to the engine or to the wheels. And then plug-in hybrids are becoming much more common out there. Gas and electric motors linked to a common transmission, much like before. Generator and motor are generally grouped in the transmission assembly, but it is a much larger battery with a greater range. Gas engine is only used under higher load conditions. So it's kind of like an EV with a gasoline engine or diesel engine backup. So that's what you're going to get with the plug-in hybrids usually. It's good. So there's different battery sizes depending on what kind of vehicle it is. Electric's going to be huge. Hybrid's going to be on the smaller end, and then a plug-in hybrid's going to be either closer to the EV size or kind of a medium in between type of thing. Different components, going to be very similar to the EV, but smaller scale, like I said. So it's going to have an internal combustion engine. It's going to have a battery cooling system, just the same, generator, voltage converter, regenerative braking system, and an electric motor, just like our EVs. Battery, it's going to be multiple small low voltage battery links in series, results in high DC voltage, 300 to 400 plus, like we said, nickel metal hydride or lithium ion, and it's often smaller than an EV. Oftentimes, like I said, on the Toyotas, they're just tucked in the rear underneath the seat. I found this comparison chart today, actually, on an article in Car and Driver, and this is on Ford's different systems. So here is an example of what you're going to see. So we're going to talk like energy density, right? So energy density is how much energy is available per cell, or how much weight on the vehicle. So in this case, the F-150 hybrid has 76 cells for a capacity of 20 watt hours per cell, which gives us 1.9 kilowatt hours per 100 pounds of the vehicle, or the pack, sorry, pack weight. And this pack's pretty small, 77 pounds, 1.2 cubic feet. And then we see the Escape plug-in hybrid vehicle. Like I said, that's usually going to be a little bigger. It's 364 pounds, 3.9 cubic feet, runs at 300 volts, 84 cells, 171 watt hours. So it gives me 4 kilowatt hours per 100 pounds of the pack. And then the Mach-E extended range, which is going to be the biggest battery that they have, and it's only EV. So that's going to be a 1,300 pound battery, 16.2 cubic feet it takes up, 343 volts. Ford likes to stay under the 400 volt because that's kind of what they use for their systems. 376 cells individually, so that's a very large pack. Well, 16.2 cubic feet, that's pretty large. So 7.5 kilowatt hours per 100 pounds. So there we go. So that's the difference between a hybrid, a plug-in hybrid, and a full EV. You're going to see the difference in the size of the battery packs, right? The generator in there is going to be used to charge the battery. It's going to also be used to start the engine. They run it in reverse with a gear, or run it forward with a gear set, and use that to start the engine. Doesn't have a traditional starter. It uses the generator to do it, and that generator outputs an AC voltage. So in this case, we need an inverter or converter for that. So you got AC three-phase. It goes to the electric generator back to the electric motor. Once again, it's three-phase. And actually, the AC compressor runs off 200 volts as well. A hybrid vehicle computer in there, 200 volts down there, back to the battery pack, and there's a 12-volt auxiliary battery as well. And like I said, AC three-phase. So you're going to be running into some of that. The regenerative braking system, like we discussed before, transfers energy from braking to charge the battery. Uses the electric motor to brake. Motor runs in reverse. And hydraulic brakes, of course, are still used for that. Electric motor, high voltage, used to drive the wheels, used to charge the battery during regenerative braking. Most are brushless type DC motors. And it's going to be that three-phase. Could be AC as well, that three-phase. Power flow. So some vehicles actually will tell you on the driver information display how that power is flowing throughout the vehicle. So we got a couple different options. Full electric mode, it's coming out of the battery through the electric motor to the wheel. Hybrid mode, it's going to run the electric motor and the engine to the wheels. Engine mode only, it's going to run just the engine to the wheel. Those are kind of your three most common phases you're going to going down the road, right? So you're going to probably be putt-putting around town. You might just be on the electric motor for a lot of time. And then when we get into hybrid mode, it might run both, and then engine, when the battery gets probably low or something like that. Or if I'm cruising, I'm probably an electric motor too. Charging, it's going to go from the engine back through the electric motor to the battery and also drive the wheels. Could also be coming from the wheels back to the battery and the engine charging the battery. That's usually on a coast, I guess, and then engine to electric battery, and then also run the electric motor to run the wheels. So that's kind of a cross there. And then the last two is going to be charging from the wheels. That's when you're using engine braking going that way, and then charging just off the wheels back there. So this one's probably the least common, I would think, running the engine backwards. But that's your different phases that you're going to see. And then idle mode, of course, nothing's going on. Engine braking, it's just going to go back to the engine. And then just regular charging, the engine can run to charge it without having to run the wheels. All right, so that is EVs and electric, the slides anyways. Now we're going to go to live. Live, live, live. All right, just give me 1 second here. Just got to look at something here. All right. Just get this in here real quick. Okay, so let's look at a couple different vehicles. First one I want to look at is a Highlander hybrid. So that's going to be an all-wheel drive hybrid vehicle. And we're just going to come in here. And if you have a hybrid vehicle, you might find a couple things up here, but more than likely you're going to need to scroll down if you have it categorized and down to hybrid and electric vehicle category. So you got hybrid control, motor generator, power source, and rear motor generator as well. So like I said, it's all-wheel drive, so it's got front rear motors. I go into hybrid controls. I got codes and data, actuator tests. Going to be a bunch of like different relays, activate the inverter water pump. You might need to do that to bleed it. Radiator fans, solenoids, air shunt valves, coolant distribution valves, and so on. Back up. Routine tests. We got a compression test for the engine, hybrid battery charge. Puts it into a charge mode to use with a special charger. So hybrid battery charger connected, charger cable not connected, and turn the ignition switch off before resuming operation. Because sometimes you cannot diagnose the vehicle unless the battery is to a set amount of charge, and it won't start. So you have to charge the actual hybrid battery before you can do anything. So initiates charging from the high voltage battery charger. Hybrid battery charge activation status we found in the data list. So that's going to be your current value right there. Active test cannot equalize the voltage difference of battery cells. It's just going to really just initiate the start. So you'd hit start, charge it, it'll charge it. When it's done, you can hit stop, and you'll be done. And it's really just going to give you like your percent charge in there. So that's kind of interesting. Control the cooling oil pump, transmission oil pump, grill shutters. And then you can customize some settings in there, body control with torque demand. And then special functions in here. We're going to have ACT precision learning, AT code registration, grill shutter initialization. So if I change my grill shutters, I have to reinitialize them. Battery status information updates. You can go in there. When replacing a high voltage battery stack, it's necessary to update the battery status info stored in the ECU. Turn the lamp off on the meter after the battery stack is replaced. Use this function to update battery status info temporarily, since it takes too much time to update the information automatically by plugging charging. So it just kind of forces the ECU to relearn the battery status. It just goes through, and then it would be done. In this case, I'm in a simulator, so it's not going to let me do it. But it would just go through and do that. Even mode cruising range reset, grill shot, like I said, inspection mode, check mode, etc. So quite a few controls in there in the hybrid control. Let's see, let's go into motor generator. So on the motor generator, we got some actuator tests for the inverter cooling fan. Routine tests is going to be generator oil and cooling oil pump, and then your system tests. Resolver learning and initialization right there. Remember how I talked about the resolver? You got to relearn it and initialize it. Used to learn and initialize the correction amount for resolver variations. Execute relearning the resolver when parts are replaced. Refer to the repair manual when you use this function. Engine power switch on, vehicle stop, vehicles parked on a flat surface, shift lever on neutral park, steering wheel center. There's an initialization function and a learning function. So if I have a new one in there, I need to initialize it, then I need to do learning. If I'm using the same one, I would do a learning. I'm just going to exit because it's going to error me out again. Also on some hybrid and EV vehicles, like I mentioned earlier, we also have got a component test on some of them. Depending on what the vehicle is, if you see hybrid electronics, it's going to show you in there where you would go. Now, depending on what it is, what they have for components, you're going to find a few components. You're also going to find things like how it works. So in this case, cooling pump, we can go in there. It's going to give us our connector views and all that and how to test it, what we should see. So you can do a DC voltage test, check for voltage, and we can do a signature test to check for pulse width. So it's going to be a pulse width modulated thing. And then all the other stuff is going to be like high voltage warning. It's going to tell you different things to do. Inspection mode, how to put it in inspection mode. Safety gloves, talks about that, different part numbers for that. Auxiliary battery, talks about the 12-volt battery. Service plug, is going to talk about that. I will say one good practice if you're doing this and you pull the service plug. There's someone who mentioned it a couple years ago when I did one of these classes. They're like, oh yeah, we do lockout tag out. So they actually put it, use like a tag out for like an electrical panel, do lockout tag out, and then that way, no one's going to accidentally put that plug in. And then also sometimes they're like, yeah, we make the tech put it in their pocket too, the plug. So that's good for that. And then some abbreviations used as well. So that's the Highlander. Let's look at Hyundai Kona EV. Actually, let's look at a Kia Niro first. The Kia and the Hyundai are going to be similar, but not exactly the same. So it's going to say hybrid and electric vehicles contain high voltage. So this one's a hybrid in this case because it's got an engine. Also notice it's like everything else, like analog brakes, electronic parking brakes, tire pressure monitors. It has all this stuff. Even if it was a full EV, it would have all that stuff. So hybrid and electric vehicles, we got battery management system. So that's going to have a few tests in here for like fans and stuff, main relays. System tests is going to have inspection of the 12-volt battery status, state of charge calibration, isolation breakdown detection function. So it's going to check the isolation in the battery pack and make sure it's not broken down. Inspection of insulation resistance of high voltage parts in the PHEV plug-in hybrid electric vehicle. So a couple good tests there. Data, if you go in there, it's going to give you your cell, should give you your cell data. Yep, cell voltages, right? On your different cells in the battery. State of charge. Things like that. So if I'm looking at battery voltages, I want to see them not vary too much. In this case, of course, we're in a simulator, so it's going to jump around a lot. We want to see just like, I think it's like 0.3 of a volt is the spec between cells. And I'm going to show you a little test that we have on the next vehicle that has that. So that's the Kia. I actually never checked to see if we got a component test on that. No, looks like we don't. It doesn't even list it. So let's go to the Kona. So in this case, this should be the full EV, I believe. Yeah, full EV. So it doesn't list engine or transmission in there. The ABS, airbags, occupant detection. It's got all the ADAS stuff. So all your normal 12-volt stuff still applies. Body control modules, auto AC, cluster, electronic power steering, that sort of thing. Motor control unit. We're going to have a force in the radiator fan. System test electric water pump control. So this is what you would need to do in order to bleed the cooling system after it is filled or serviced. You need to use that. And then battery management system. So in this case, we have a system test for high voltage battery health check. Some Hyundais and Kias have this, some don't. But this one does. And we'll check the health of the high voltage battery. This is an automated test that we developed for this. I'm going to continue. So in this case, the first thing it's going to do is EV battery health check. So it's going to take some data out of just the regular data PIDs. State of charge of the battery system, in this case 0%. And status of health, new product should be 100%. And of course, this is 0% because I'm in a simulator. So hey, continue. Guess what? Fail, because I got 0% battery. So it's going to give you a pass fail, which is a quick check. And then the battery health check. Remember how I talked about having cell variances? So maximum cell voltage, minimum cell voltage in the pack. Which cell number had the maximum voltage and which one had the minimum voltage number? So that way you can go in and see, all right, so I can take a look at the data and see who has the lowest and who has the highest after that. So health check completed. I could print that out as well if I needed to. And then you can do state of charge and state of health calibration as well. So that's our, it's got a couple other modules in there too, like the motor control unit. That should have electric water pump control again. Functional tests, radiator fan, just like the last one. And then lastly, we couldn't talk about electric vehicles without talking about Teslas, and that was recently added last year. So we do have scanner functions in here for that, of course. Of course, it is a purely electric vehicle. Never had a gasoline engine in it, so they don't necessarily have to follow the same rules. So they do have a lot of different things going on. You do have to put it in service mode, so it tells you how to put it in service mode in there. So you go into the screen and hit the icons and do what it needs to do to get into service mode. And sometimes you need to unlock the gateway as well when you're doing work on the car. But as far as hybrid and electric vehicles, since it is a pure electric vehicle, we have an awful lot of different systems in that case. Battery management systems going to have a bunch of special functions, different results, clearing those resets, resetting different service codes, hard resets. So Tesla's a lot different than any other vehicle because, like I said, they're purpose-built as EVs. So different codes that might set, you can just reset them in here, soft resets, hard resets. A lot of what they tell you in their service information, which, by the way, a lot of it's free. You go into their service information, it's going to tell you, oh yeah, this, and then go in here and do this reset and see if it worked. Because oftentimes it will, just like kind of unplugging and plugging it back in again type of thing. So since it is purely electric, oftentimes that is what you need to do in order to make that car work again. Guided component test, it does. We do have component tests on ABS right now. Hopefully adding some others in the future, but things like the ABS module, brake pedal switch, right? We can go in there, we can test it. We need to. Electric brake booster, parking brake actuator, iBoost pedal sensor. So it's got a little pedal sensor on that. Sure. In terms of control signals for the electric motor, while a two-stage gear unit converts the torque of the motor into the necessary boost power. Yaw rate sensor, things like that. Wheel speed sensors, right? So it's going to have all that normal 12-volt stuff on it too. All right, so that is hybrids and EVs. Let's talk about what we're going to talk about next week. So next week, we are going back to the top with our OEM-specific ADAS training for BMW. So we're going to talk about the differences, some unique features and functions on BMW vehicles when it comes to ADAS, and yeah, just kind of go through it next week. So if you want to join us live, same as always, every Tuesday, 6 and 9 Eastern time, go to snapon.com/OT if you want to join on Zoom. Otherwise, YouTube is streamed at 6 p.m. Eastern at Snap-on Diagnostics is the channel name. Otherwise, 9 p.m. Eastern is to our Snap-on Diagnostics product and training page over on Facebook. YouTube, if you scan that QR code, it will automatically bring you there and subscribe you. If you want to see any of the other videos in this series, all the way from Intro to ADAS I did back in 2020, all the way through our OEM-specific ADAS training, or this class, which is getting archived up there right now, 114 episodes for your viewing pleasure, and you can just kind of go through them at your leisure. They're all free. They're all about half hour, 40 minutes. And, you know, if it's free, it's for me. That's what I always say. It's good, you know, good overviews of what we need to talk about. So once again, scan that QR code if you want to go. Also, do we have your email address? If we do not have your email address, you might be missing out on some topics like Tech Focus articles, SureTrek blogs, quick tips, new product releases. We did just release a new product this past week. So, and that, from what I hear, they're selling pretty quick. So it's called the Triton, and you want to talk to your franchisee about that. But you would have gotten an alert about that. We would have sent out an email and said, hey, check out this new product, it's Triton. Also blogs, quick tips. Here's an example of one for a stretch timing chain, how to diagnose that. So if you're not getting these types of emails from us, we're not going to spam you 5 times a day like some companies do. It's going to just be maybe a couple times a month. So scan that QR code. It'll bring you to a form where you can go in and fill out your particulars and start getting emails. All right, almost time for questions. If you do have a question on Zoom, just find that Q&A button, type it in. And on YouTube, of course, use the live chat function if you want to do that. Before we do that, though, I want to talk about my buddy Keith, who also does new product training. So his training is also free. On Wednesday, it's on Zeus and Zeus Plus. Thursday, it is on Triton and Apollo tools. So I suspect that Triton one's going to be fairly heavily attended because new tool, new product. People want to learn about how it works. So it's at 7:30 Eastern, one class a week. Snapon.com/OT if you want to sign up and join over there. Getting ahead of myself. All right, let's get the questions. Looks like we got a couple comments on YouTube, anyways. Let's see. Nick says, "Good evening from London. As always, very welcome. It's 11 o'clock at night. Get some sleep." Let's see. And I know, Nick, over in Europe, you need certifications to work on an EV. So we actually have a certification class over there, over in England. He does say, please, before you work on EV or hybrid vehicles, please check whether the software updates are done before you work on the vehicle. That's good advice. Because I believe oftentimes a lot of the fixes get done in software updates as well, because they're basically rolling batteries with computers attached. Jaylee Lobo says hello, Jason and Nick. And Willie says thank you. Nick says can't wait for the next video. And that looks like clear the big board. So with that, thank you very much. Thank you for taking a little bit of time out of your day to spend a little bit of time with me. Hopefully we got some good little overview on hybrid and EV vehicles, how they're similar, how they're different, how we can work on them. Hopefully I'll see you next week for ADAS on BMWs. With that, enjoy the rest of your night. Enjoy the rest of your week. Enjoy your weekend. Have a good night and take care.